Good afternoon. This is the last in our series of videos just to remind you about how to make very simple measurements using the metric system. First we talked about length, then we talked about mass. Today we're talking about volume to end out the week. I promise there won't be so many videos every week from here on out through the rest of the 9 weeks, but we wanted to be sure you got a good review as we're using this in class. So just to talk about the definition of volume, the definition is that it is the amount of space an object takes up. So this is talking about three-dimensional objects. Basic unit that we use for metric system is the liter, and we abbreviate liter with a capital L so that when we put a number in front of it, we don't confuse it with the number 1. Some other common units that we'll see in the classroom over the next few days include the milliliter, so this is one of the smallest units of measurement, and we abbreviate that with an ml, and this is when we're measuring liquids. If we're measuring solids, the common unit you'll see is the cubic centimeter, and we abbreviate that with a cm and then a 3 to show that we're talking about 3 dimensions. One cool thing about centimeters cubed and milliliters is that you can convert them pretty easily. So if I have 1 centimeter cubed, that's actually the same thing as 1 milliliter. So if I'm trying to measure the volume of a solid that has kind of a weird shape, I can actually drop it into water in the graduated cylinder and see how much the water level changes in terms of milliliters. And then that can tell me how many centimeters cubed it is. And we'll do that in class. Equipment that we're going to be using when we practice this include the graduated cylinder, which is the long, tall, skinny looking object that you use with all the lines on it. The beaker is shorter and it measures larger amounts of volume. So these are both for liquid. When we're measuring the volume of a solid in this class, we'll use the metric ruler or even a meter stick depending on how big it is. So we've got a few examples of measurement in terms of how large the object is. The first is if I had a can of Coca-Cola, if you actually hold up one of those cans and look at the bottom of the label, you'll actually see a measurement for what it would be with our system we use in America and also the metric system. And when you do that, you'll notice that it's measured in milliliters. And remember the capital L instead of lowercase. If I have a bottle of apple juice, that's holding more of volume. And so instead of putting a prefix in front of it to make it smaller or larger, we've just got a plain liter. Most of the time it's not going to be much bigger than that. Now, a textbook, it's not liquid, it's a solid. So instead of using liters, we'll use centimeters cubed. So when you're doing a lab in class and measuring liquid volume using the graduated cylinder, you'll see measurements that look like this. One thing you'll notice is that liquid tends to kind of cling to the sides of the graduated cylinder. And if you look at it across the side, you'll notice that it dips in the bottom. This curve is called meniscus. And what you need to do is look for the place where the water or whatever the liquid is settles in the middle. And that gives you the most accurate reading. On your notes, what I'd like you to do is change these two numbers. I think the number says 5 and 6, and what I need you to do is change it to 3 on the bottom and then 4 at the top. To me, it didn't make much sense for it to have the small number at the top and the large one at the bottom. So I just want to do this as an example instead. So looking at the bottom of the curve, we need to see what this measurement is. Each one of these lines represents 1/10 of a liter. Okay? So if I'm between 3 and 4, I know my whole number is 3. And then I have a decimal point. It's only one line above the 3, so my decimal is going to be 1/10. Looking at this example, I have 50 milliliters and 60 milliliters. So once again, these lines represent just one unit of measurement. Okay? So this half point is a little bit bigger for us to be able to point that out pretty easily. And we're just one step up above that. So my whole number is 50. Oh, I'm sorry. I told you wrong. Let me change that. And it's actually good to see me make a mistake, so that way if you make a mistake later on, you'll know how to fix it. We need to pay attention to this. This goes from 50 to 60, so that means all of the steps in between will actually equal 1 whole milliliter instead of tenths, like it did over here. So if it represents 1 whole, we're just going to count by ones until we get to the meniscus. So we're here at 51, 52, 53, 54, 55 is the halfway point, and then 56 is right here. So we'll have to correct ourselves and put 56 as our answer. So we've done some conversions on our other notes, and we wanted to finish out doing this with these notes on volume. And remember, from the past 2 days, we've said that milli means 1,000th. And so when we have 1 liter, that's the same thing as having 1,000 milliliters. Okay? And a second ago, I told you that milliliters and centimeters cubed are the same measurement. They equal each other. So if I have 33 milliliters, how many centimeters cubed do I have? You should put 33. It's the same thing. So you can convert easily from solid to liquid and back again. So that is it for our measurements notes. You have survived our first set of notes in science class. You should pat yourself on the back. If you have any questions, be sure you email me at sparish@amherst.k12.va.us. If you'd like to post underneath this video or send me a direct message, you can use Edmodo. And if you'd like to use the phone, if it's during school hours, you can call the school at 946-0691 and it's extension 27017. And if you remember, please do the video check. If it doesn't work, we can try to work out a way for you to take it during class. I hope you have a great afternoon, and I will see you tomorrow.